Right, hi everyone, good day and welcome to our lesson on biostatistics. Today we are looking at inferential statistics. I'll be looking at a particular type of statistical hypothesis testing which is called chi-square. A very brief introduction or history to chi-square. Chi-square was, invented in the 19th century by a person called Pearson. Alright? And one of the criteria for us to use chi-square is that the population should not be normally distributed. That is, the population should be skewed, right? Or another way we can put it, the population should be highly distributed. Alright, now, we'll be looking at test of independence of attributes, and chi-square, this symbol can be used to represent chi-square, something like an x, right? That is the chi-square, and the formula for chi-square is summation of observed value minus expected value squared over e, and that is the formula for chi-square. Are we together? Now, so we have an example on the board for us, and they said the table below shows the data obtained during an outbreak of smallpox. So there was an outbreak, and the table is giving us some information about this outbreak. So those that were vaccinated, right, and those that weren't vaccinated or not vaccinated, then we'll see on the column, we have two columns of attack and not attack. So this is it, attack and not attack. So we have two columns and two rows. And this is the total this way, and then total this way. Now, what is the question telling us? That we should test the effectiveness of vaccination. So we want to know if actually vaccination had any significant influence on the attack of smallpox. So test the effectiveness of vaccination in preventing the attack from smallpox. Then test your results with the help of chi-square at 5% level of significance. That is the question. Alright, now in hypothesis testing, usually there are some steps that must be followed. So we don't just go and start solving. Alright, so let's have the steps out, let's have the steps written out. And the step 1 in hypothesis testing is that we should state our null hypothesis, which is HO, and then we also state our H1 or our HA. Some authors use H1 or HA or H1. So this is our null hypothesis, and this is our alternate hypothesis. So we want to know if vaccination is effective in the prevention. So what would be our null hypothesis, right? So vaccination is not effective. It's not effective, right? It's not effective in the prevention of smallpox. Okay, obviously our alternate hypothesis will be the opposite. Alright? So that means vaccination here now will be what? Vaccination here is effective. Alright, it's effective in the prevention of smallpox. So, just a way of introduction, null hypotheses are hypotheses that state that there is no significant relationship between the variables in question. So we have two variables. One variable is vaccination, and the other is the attack of smallpox. So we want to know. So the first one we are saying that vaccination is not effective. Alright, so now we have done the first step in hypothesis testing. The second step is that the third thing is that we state the level of significance. And from the question, the level of significance was actually given, which is 5%. But in questions where level of significance is not given, you can just go ahead and use 5% level of significance. So our level of significance, LOC, right, is 5%, which is equivalent to alpha value of 0.05. Alright? That is the alpha value of 5% level of significance. Now the next thing now is for us to calculate, which is now our third step, right? Our third step is to calculate our test statistics. So calculate the test statistics. Okay, now, so let me explain something. Let me write the formula again. Chi-square is equals to summation of observed values minus expected value, everything squared, then over E. This is the formula. Now, if you look at the question, you see 31. 31 is your observed values. Is your observed value. 469 is the observed value. 185 is the observed value. Then 1,315 is also observed value. So where are we going to get our expected values? We are the ones to calculate our expected values. Are we together? As I said, we are the ones that will calculate our expected values. So to determine our expected values, expected values, the formulas we are going to use, E is equals to column total, right? So let me write CT, that is column, this is column, right? Multiplied by row total, this is row, right? Everything all over ground total. Let me take it again. To get the expected value of each of these are observed values, right? These four values here are observed values. So we need to get the expected value for each of them. So the formula for expected value is column total multiplied by row total all over ground total. So let's take the first one now. The first expected value. This is, we want to find the expected value for 31. So expected value of 31 will be column total. Column total is 216. So 216 multiplied by row total. Row total is 500. Everything over what? Over ground total. Ground total, which is 2000. Alright? Then let us go to the other one, which is expected value for 469 will be what? Column total again, which is 178. 1784 multiplied by column total, which is still 500. Everything over 2000. Alright? Let me clean it up so that I will use this side to complete it. Alright, now expected value now for 185 will be what? Still, our column total is 216 multiplied by, now you are coming to the second row now, not the first row, multiplied by 1,500 over 2,000. Alright? Please we'll write the answers later. Let's just finish. Then the last one, expected value for 1,315 will be what? This is our column total, which is 1,784 multiplied by row total, which is 15 all over 2,000. Alright, so let me just absorb them. Let me just write the answers out. Okay? Now for the first one, which is expected value, our answer is, if you use a calculator, your answer is 54. If you use a calculator here, your answer is 446. Alright? Your expected values here, for the third one, the expected value is 162. And then for the last one, your expected value is 1338. Alright, so let's take it again. This is a formula we're going to be using, and in the question, only observed values were given. So we are the one that will look for what? We look for expected values. And to get expected value, or to determine expected value, the formula we use, expected value is equals to column total multiplied by row total all over ground total. And then we have done all of that. Now please, I must stress this, very, very important, that expected values and observed value must go hand in hand. That is, I cannot just carry this 31 now and then mix it with these other expected values. I'm going to get a wrong answer. So they go hand in hand. So I'll clean this side so that I'll go into the calculation proper. All right. So the calculation has two methods. All right, and some of my students prefer, some say they prefer the formula method, some of my students say they prefer the tabular method. So anyone you choose, I'm going to solve the two of them, right? Then you choose the method you prefer. But I'm going to start with the formula method. Okay, the tabular method, sorry. Now, so look at what I'm going to do. I'm going to write the observed value here, okay? Then I'm going to write the expected values. Now let me finish with this one. So what was our first observed value? It is 31. 31. Then what is the expected value for 31? Expected value is 54. Are we together? Then the next one is observed value is what? 469. What is the expected value for that? Is 446. The third one is what? 185. Then the expected value for that is 162. Then the last one, the last observed value is 1315. The expected value is 1338. Now, so the next column will be O minus E. O minus E. Are we together? Now that means O, this is our O, and this is our E. So if you do that, you are going to get minus 23, 23, 23, minus 23. Very easy. Are we together? So the next column now will be O minus E, everything squared. Are we together? O minus E, everything squared. That means I'm going to square these values, right? This value and this value, difference is just this square. So I'm going to square this value. So if I square this value on your calculator, you are going to get 529. Okay? Now since all the values are the same, everything will be 529, 529, and then 529. Don't worry about the negative, because when you multiply 23 by minus 23 by minus 23, it's going to give you positive. Alright, so I'm going to squeeze out my last column on this other side. Okay? Alright, the last column will be O minus E squared over E, which is actually our formula. Are we together? What does it mean? It means, look at it, O minus E squared is this value. Then I'm going to divide it now by E. This is my E. So for this place, I will say 529, right? On your calculator, when you punch it, 529 divided by 54, it will give you 9.796. Alright? Now, if you do 529 divided by 446, right? It will give you 1.186. Please always make it after the 3 figures after the decimal, right? All right. Now the next one, if you divide 529 by 126, it will give you 3.265. The last one, if you divide 529 by 1338, it will give you 0.395. Now, what is chi-square? Chi-square is the summation of this column. So that means if I want to get the chi-square calculated value, all I need to do is to add up all these answers and it will give me my chi-square. So if I add up everything, summation of all of this column, it will give me 14.642, and that will be my chi-square value. Alright? Very simple, right? Okay, so that is the first method on how to go about calculating chi-square. Now this is, we call it tabular method, because obviously I'm meant to draw table like this, you understand? I'm meant to draw table. This is the first method. Now the second method is formula method, and I actually don't used to like that method because if you miss any step, you can easily get confused. So let me just do it. So this is, well, all of them will still give you the same answer, right? Now, so let me go ahead and do that one now. So this one now I'm going to use the formula method. What is our formula? This is our formula, right? So for the first one, chi-square is equals to what? Observed value is what? Our observed value is 31. So I'll write 31 minus, right? I'm following the formula now. Minus expected value is what? 54. Then everything I'll put them what? Squared. Then all over what? All over E, which is still my 54. Now that is for the first observed and expected value. Then I will put plus because this sum means plus. I'll go to the next one, which is what? 469. 469 minus 446. I'll put everything like this, squared. Then all over what? Expected value, which is 446. Okay? Now, the third one, sorry, will be 185. 185 minus my expected value, which is 162. Everything squared over 162. Are you seeing it now? Then the last one will be plus 1315 minus 1338. Everything squared all over 1338. Now on your calculator, if you solve all of these answers, for this one you are going to get 9.796. If you do all of this value, it's going to give you 1.186. If you do the third one, it's going to give you 3.265. Then the last one will give you 0.395. And if you add up everything, it's going to give you the same answer as this. Are we together? So these are the two methods you can use to calculate chi-square. Either use the tabular method or you use this direct formula method. But as I said, this one can be tricky because if you make any mistake, it can actually give you a very, very wrong answer. Now, we have calculated our chi-square. The next step is we need to determine the degrees of freedom. Alright? So, the next step in our calculation is to determine degrees of freedom. So, we want to determine degrees of freedom. Now, degrees of freedom in chi-square, the formula for degrees of freedom is row minus 1, then column minus 1. Okay? What do I mean by that? To determine degrees of freedom for chi-square, why I'm saying chi-square is that every statistical test has its own formula for degrees of freedom. But for chi-square is R minus 1, R stands for row minus 1, then C stands for column minus 1. So remember we had 2 columns and then 2 rows. So that will be 2 minus 1 and then 2 minus 1. Everything will give us what? 1, obviously, because this will give us 1. 1 multiplied by 1 will give us 1. Now, the next thing now is that we want to determine, okay, this is like step 4. Now, step 5 is I want to determine the p-value or the critical value. And for you to determine the critical value, you need to go to chi-square table, alright? You go to chi-square table. When you go to chi-square table, you know chi-square table have the vertical axis and the horizontal axis. So on the horizontal axis, you see your degrees of freedom. And then on the vertical axis, you see your alpha values. But since we are using 5% level of significance, which is equivalent to alpha value of 0.05, you check it, and then you check for degrees of freedom 1. And your answer, what you are going to get on that table, your p-value or your critical value, right, using the chi-square table is equals to 3.841. That is, you can also call it p-value or critical value. Now this one is gotten with that chi-square table. Now, so that means we are having two answers now. We are having one answer, calculated value of chi-square, and then we have critical value, or we can call it chi-square critical value. What did I just say? We have two values now. We have chi-square calculated value, and then we have chi-square critical value. Now, so we want to compare to know whether to reject. So, and that leads us to the next step, which is what? We state our decision rule. We state our what? Our decision rule. And what is our decision rule? Now, listen. Now, let me clean this side since we are done with this one. Now, if the chi-square calculated value is greater than the chi-square critical value, right? We reject the null hypothesis. That's our decision rule. Let me explain. That is, you know, I say we have two values. We have the chi-square calculated value, and then we have the chi-square critical value. So now, what will help us to decide is if our calculated value is greater than the critical value, then we reject the null hypothesis. Now, so let's look at it again. Now, what is our chi-square calculated value? 14.642. Obviously, this is greater than 3.841. That means, obviously, we are going to reject what? We are going to reject our null hypothesis. What was our null hypothesis again? We said vaccination is not effective in the prevention of smallpox. So we are going to reject that. That means if we are going to reject that, we are going to accept the what? Alternate hypothesis, which state that vaccination is what? Effective in the prevention of smallpox. So, using this rule, I can now say that conclusion, right? Since the calculated value, right? Calculated value is greater. Let me just use the sign. Is greater than the critical value, right? We reject the HO, right, in favor of HA. So that means the vaccination was what? Vaccination was effective or is effective. So you can use was or is anyhow, all right? Forget about the tenses. Is effective, right, in the prevention of smallpox. So that is that about chi-square, all right? So if you don't understand, please play the video again, and then I'm very sure you understand. Thank you very much, and see you in our next lesson.